Hello everybody, this is my first test video of teaching random materials in a video form because sometimes I don't have the time to go in the Gmeet. So yeah, hopefully the material I'm teaching you today will be useful and you'll be able to use it in your daily life until the day you die. How lovely. Anyway, so what am I teaching you anyway this time around? So I'm teaching you, wait, how do you pronounce this? Wait, fudge, what's,
Combinatorics.
Oh yeah, combinatorics. Okay, so basically, now I'm gonna teach you the basics of the part B of the combinatorics, which is the weird number and letter arranging thing, whatever that's called. So now I've written down 4 easy steps how to solve these types of questions step by step. So first of all, prioritize the requirements. Maybe they want you to sort out the numbers to make an even number, an odd number, or even sort the letters so that the vocal letters are in the front, the back, middle, whatever. You do you, mathematical questions. Anyway, after you fill in the requirements, then you fill in the rest of the numbers that didn't get used and got neglected. And then you finally recheck, just in case you made any mistakes. Then again, this is easier said than done, so let us do some very simple questions to practice, So let's start off simple. How many gibberish words we can make by rearranging the words in modern? So modern has 6 letters, and we just need to rearrange these 6 letters to form gibberish or whatever. And the requirements are the first 2 letters must be a consonant. What are consonants? Basically, the letters that aren't vocal letters, which in this case is MDRN. So first, we fill in the requirements by writing down MDRN in the first letter slot. Then, you eliminate the top letter here, M. Then you write down the rest of the remaining letters, and then you eliminate the top again. Then, after filling the requirements, you fill in the rest that didn't get used. You write in RN and then OE, the vocals that didn't get used in the first 2 letters. Then you eliminate the top, move again, eliminate top, move again, eliminate the top, move again, eliminate the top, then you get everything. Now you count by multiplying all the amount of letters in each row. 4 times 3 times 4 times 3 2 times 2 times 1, aka 4 factorial. You times everything, you get 288. Yes, 288. Let's go. Yeah. For the next question, what if you need to fill in the requirements on the back of the set of numbers or letter? In this question, how many odd numbers can you form with 4 different unique numbers with the numbers 0, 1, 2, 3, 4, 5, 6. So first of all, you identify the requirements by, first of all, every number needs to be different. The number must be an odd number. So if you want an odd number, the back of the number should include an odd number, which is 1, 3, 5, 7, 9. Yeah, that's basically it. So in this question, you want to prioritize the requirements, right? But in order to make an odd number, the back needs to be an odd number. So, okay, hear me out. First of all, you fill in the requirements, which is the back of the number, which is 1, 3, 5. Then you eliminate the 1. Okay? You eliminate the 1. After eliminating the 1, Then you fill in the rest of the numbers, which is starting from the first number, but without the number 1, okay? Because he's already used in the fourth slot, okay? Then you write 2, 4, 6, 3, 5. What about 0? Where's 0? 0 is not allowed on the first number because it will form something like 0, 2, 1, 3, and then that'll be weird. Instead, you put the 0 starting from the second number, and then you do the usual eliminate the top, then fill in the rest, eliminate the top, fill in the rest until everything's full. You got it. Now you times everything. 5 times 5 times 4 times 3, 300. Yep, okay. Yep, that's how I did. Now time for a more interesting question. How many even numbers you can arrange with 3 different unique numbers? So if the question doesn't state what number you have to use, you just have to assume that you have to use 0, 1, 2, 3 until 9. So what's so unique about this question? To solve it, you need to split the question into 2 cases, because there's 2 different possibilities. Okay, let me explain. So in the first one, since you have to prioritize the requirement, an even number should consist of 2, 4, 6, 0. And then you write the rest. 1, 3, 4, 6, 7, wait, 5, 6, 7, 8, 9, 0 here. Okay, 3, 4, 5, 6, 7, 8, 9. So 8 times 8 times 4. Oh, wait. Oh, wait. My bad. I meant 2, 4, 6, 8, 0. So that means 8 times 8 times 5. My bad. So yeah, so basically you prioritize again the first number and then you eliminate it. Then you go back to the front, okay? Total it becomes 320. But then 0 is a special case. If you use 0 as the number in the back, then it will result into an amount. Let's prove it here. So if you write 0 here, 0, 2, 4, 6, 8, okay, you'll eliminate 0, then write the rest, 1, 2, 3, 4, 5, until 9. Then you eliminate 1, and you fill in the rest. Look, now it's 9 times 8 times 5. This is because 0 can't be used on the first number slot. So it totals in 360. But the question isn't solved yet. How do you calculate this? So, since 0 has its own special case of the amount of possibilities being 360, and it's different from if you put 2, 4, 6, or 8 in the back of the number and that the result is 320. So what you want to do now is total all the possibilities up and divide by 5. What do I mean by that? So 320 times the 4 possibilities, if you put 2, 4, 6, or 8 in the back of the number, and then plus 360 times 1, because that 0 is the only 0 makes that amount of possibilities. Then you divide by 5, and you get a number of that number, 328. Yeah. If you're still confused, I have another way. I'm going to explain in a bit. So the second way of looking at this question is it's a bit similar. So first of all, you want to fill in the requirements, aka putting the 2 at the back. But In this case, we just want to guarantee that there's a 2 in the back. Only a 2. Only a singular number. And then you fill in the rest without the 2. Blah blah yada yada yada. Okay, 1, 3, 4, 5, 6, 7, 8, 9. So for this case, we want to imagine that the back number is a guarantee 2, or a guarantee 4, a guarantee 6, or a guarantee 8. And you times it by you total it by 8 times 8 times 1, and then the 4 possibilities. This is basically the same way, just without the big ass numbers. Then you create the second case, which is the if the number has the 0 is a guaranteed back of the number. You put 0, you'll need everything, the front, the middle, and you times it 9 times 8 times 1. And you don't have to divide by 5 for this one. So 8 times 8 times 4 times 9 times 8. So you can group this by 8 times 8 times bracket 8 times 4 plus 9 bracket close bracket. So 8 times 41, 328. For this last question that I'm going to explain, so basically you are tasked to find, you're tasked to make numbers between 3,400 and 7,000 with the number 0 until 7, and the numbers can be the same. So in this question, you also want to split this into 2 cases. So the first case being 3,400 until 4,000, and the second case being 4,000 till 7,000. Why is that? Because 3,400 until 4,000, the second number will be 4, 5, 6, 7. But the 4,000 till 7,000, the second number could be 0, because 3,400 till 4,000 only doesn't include 3,000 or 3,100, 3,200, 3,300, and etc. Yeah. So first of all, you of course want to prioritize the requirements. But since this question wants oddly specific numbers, first of all, you put in 3, but not a 4. Why is that? Because the second number slot and the third and the fourth number slot will reach up to 7, and that means there will be a possibility this case will have numbers higher than 4,000, and we don't want that. That's in the other case. So we write down the rest: 4, 5, 6, 7. Of course, because it needs to be between 3,400 and 4,000. Then, since you can use the same numbers, you just write everything down until the very end. Okay? Then you calculate 1 times 4, 1 times 4 times 8 times 8. But in this case, you are going to have to minus 1. Why? Why is that? Look, there's 3,400 as a possibility, but that's not allowed. Why is that? Since the question is asking you for numbers in between 3,400 and 7,000, that means the number needs to be higher than 3,400 or under 7,000. So the result should be 255. Okay, now we move on to the second case, 4,000 until 7,000. So of course, prioritize the requirements. The front number obviously has to be 4 or higher. 4, then 4, 5, 6, then 7 is not allowed because it has to be in between 7,000. Okay, it has to be under 7,000. Okay, you got that? Okay. So then, since you can use the same numbers over and over again, you just fill in the rest 0 until 7, 0 until 7, 0 until 7, 7. Then you count 3 times 8, 8 times 8 times 8. Then 4,000 here is allowed because 4,000 is in between 3,400 and 7,000. The reason why again 3,400 is not allowed because it's asking for the numbers in between 3,400 and 7,000. Okay, so we total this in 512 times 3, that number, yeah, 1,536. Then you just total it up, and that's 1,791, and that's it. So anyway, that's it for today. That's all the numbers I'm going to discuss today. And if you have any questions, of course, you can ask me. I'll hopefully see your message and not accidentally ghost you guys. And yeah, thank you.